Welcome back to the Wealth Actually podcast, the show that features artists, entrepreneurs, experts, and commentators that will give you the right knowledge, planning, and guidance so you can preserve your assets and enjoy your wealth. Learn more and subscribe today at wealthactually.com. And now, here's your host, Fraser Rice.
Welcome back to the Wealth Actually podcast. I'm Fraser Rice. All of us have become more reliant on technology and software to solve problems and improve our lives. However, many of us understand less and less about the programming that goes into these solutions. Further, we forget or ignore the human element of this problem solving. In this episode, I speak with Andy Hunt, who has devoted his life to these issues. He's authored a dozen books, including his best-selling work, The Pragmatic Programmer. And on the heels of that book, he co-founded the Pragmatic Bookshelf, which focuses on books for software developers. We talk about his early days of programming and the power of community and process in the world of software design as we go into his experience with broader consulting at the enterprise level. Further on, Andy dives into what he considers to be important in the future of programming and advice for young programmers. Finally, as a consummate Renaissance man, Andy discusses how his hobbies in writing science fiction, music production, and woodworking excite his brain and inform his problem-solving ability. Welcome aboard, Andy.
Oh, thanks so much for having me.
You have had an illustrious career in and around the programming world. Maybe take a few minutes to describe where your initial interest in programming developed.
I think the thing that really kicked it off, this sounds incredibly ancient and dated, so forgive me, but it was a teletype terminal. So this thing that looks like a typewriter with that 132-column green bar printer paper in it, no screen, you type and it comes out, and then you're dialed into the mainframe on an acoustic coupler to the mainframe that's over in the next county, and you could play Lunar Lander, which was just amazing. You could print out a poster of Spock using X's and O's and ASCII art. And I saw this thing, I'm like, oh, this is so cool. It's a long way to get from that to the technology you'd see in science fiction, like Star Trek or something. But I was pretty convinced that these things were related. Banging out ASCII art on this teletype and being able to program it wasn't that far a step from having a Star Trek level computer.
When you got to the next stage, when you get past the printer aspect and you're getting to screens and graphic user interfaces, etc., what were your experiences like on that front?
There was a lot of in between there. There was a lot of command line before the GUI took off, at least for me. GUIs were a later addition as we went along there. There's plain old DOS before that, and plain old CPM, and its multi-user version MPM. And that's where I did a lot of my first work. So it's kind of funny. I've always espoused the power of the command line because that was all there was back in the day. The GUIs were something fancy being done off in some lab somewhere. And then when they first came out on something like Windows 3.1 or the early Macs, it was neat, but it was pretty clumsy to start with. It took a while for that to be the thing. But you could do an awful lot even with basically ASCII graphics. Turbo Pascal comes to mind. That was one of the early languages which amazingly had the editor and the compiler and debugger all built into one program. And that was an astonishing feat. We were doing some projects using Modula 2, which was a horrible language. I always build it as the academic version of Pascal, if such a thing as possible. It was a really stuffy, kind of a claustrophobic language, but it was one of these deals where you're compiling, and in the middle of the compile, take out disk 2 and put disk 3 in, because it had to do memory overlays, because there wasn't enough RAM on any computer at the time. The C programming language is still God's own programming language. That, to me, is the mother tongue. That is the Latin of Western languages. I am still a big fan of C.
As you were developing your expertise, what were the types of problems that attracted your attention? What were you solving with these tools as you were building your skill set?
There was the things that companies needed doing, and that was boring. That was inventory control. That was my first big system I wrote was a manufacturing resource planning system for a factory. Typical industrial data processing needs. And I find this interesting too. Back in the day, there was a difference. Computing was something they did in universities and research projects. What you did out in business was data process. It was payroll. It was inventory. It was finances, which was different I was interested very much in automation and home control at the time, the X10 protocol, getting able to turn your lights on and off using power line carrier systems. I thought that was a really cool idea. I was young then. Fast forward to the Internet of Things. The S in IoT stands for security. But this crazy idea that your light bulbs can be hacked and are Wi-Fi enabled, it's like, okay, this started off as a really neat dream and a cool idea, but that particular branch has gotten to be nightmarish.
It reminds me of the movie Maximum Overdrive, when the computers develop awareness and evil undertones.
That always happens. You got to put that big off switch right up front.
You mentioned that C was really, as you say, the Latin of programming languages and the mothership upon which all the others, the important ones especially, evolved from. What other languages were you gravitating toward as you were building your career?
I worked in C++ for 8-10 years, and it was in the early days, so it was interesting to watch it evolve from the earliest C-front implementations where C++ was just a preprocessor on top of C. And you could see where the edges leaked out. It wasn't a really great abstraction over top of it. It was pretty clumsy, but it was a nifty idea of, oh, you can add classes to C. And I think in the early days, it was simple enough that it was very workable. It was pleasant to work in. But as happens with most technology, you go over the course of time and everybody wants to add just one more feature. It's like that Monty Python movie, right? One more wafer thin mint. And of course, Mr. Creosote explodes at the end of that bit. And I definitely think that's where C++ ended. We used to have a joke that your reward for being on the ANSI committee for C++ was that you got to add a keyword or a feature, because it just seemed over the course of time to really suffer this feature bloat. And I see that happening even now with, and people might argue, but the Ruby programming language started off smaller and more elegant, and it's been adding stuff lately. And maybe that's a good idea. Maybe that's just a natural part of growth. But part of me is like, you really got to watch that. You can't just keep adding things, or you end up with COBOL again.
It's like urban planning in Atlanta. When the sprawl takes on the attributes of metastasis, you end up with this bloated, traffic-filled structure that ends up not working for anybody.
Until somebody like Sherman comes through and burns it to the ground, and then you just start over again.
Everything has a natural cycle.
We need some more programming language forest fires. But that happens. Everyone gets fed up with the status quo of the bloat of a Java, J2EE especially. That's just monstrous. And they're like, okay, we're going to go back to basics and do something very simple and elegant. And you come up with something like a Ruby or maybe a Rust or whatever. And it's really elegant and it's cool, but then you realize you're missing some bits and pieces. So you start having to add the things that business requires, that finance requires, whatever. And as you start adding in all these things that you're missing, you end up back with the thing that you were rebelling against in the first place, because now you've got all this gunk added in. And it's hard to pull it off to add these things in a nice manner.
I think for the layman, programming is considered to be a pretty solitary pursuit. And as you were working in bigger organizations, solving bigger problems that required manpower and delegation and things like that, what did you see as an adjustment on your front in dealing with the delegation or the collaboration with other programmers? And at what point does management, and I put that in quotes, of the strategy around solving that problem get in the way of execution?
It's a huge adjustment. And part of that is really a slam on our educational system, whether it's traditional university or college or even these boot camps. We're taught programming as a solo DIY thing. And that's great for a little bit, but we're never really taught to work in teams or to problem solve as teams, which once you get into the real world, that's what you're doing. You're problem solving collectively, and you have to work collectively. I've always said the two biggest skills a programmer needs are learning and communication, because we're learning constantly. Not even just the new tech, but we're learning about the domain. We're learning the emergent characteristics of the system as we're building it. We're learning how our team works or doesn't. We're learning how the politics of the organization work or don't. We're learning all the time, and we're communicating between all these entities. At a first level, we have to communicate our intent to the computer. and it back to us. Then we have to communicate with the team, with the end user, with the sponsors of the project, whatever it might be. And we're rarely taught any of that. At best, we're taught some theories of computing, like finite state automata and theorems and this sort of thing, and particular programming languages, particular environments. Maybe you're taught a little bit of technical documentation or testing, but not much. And then you're thrown into the real world where everything that you've been taught is 20% of what you're doing, 10% of what you're doing. So that's a huge problem. Then you get into a larger corporation. Communication is now the most difficult thing to get right. Because on the one hand, you've got hard realities of day-to-day coding. NPM is a nightmare. It's a disaster. And you have to work with that and all of its dependency management. And oops, somebody pulled that thing out of the repo and now none of this code works. And this version doesn't work with that version. And just day-to-day annoyances and technical things. And that world is a couple universes over from the forces and tensions of high-level strategy and the business world and what business owners and sponsors have to accommodate and deal with. We speak completely different languages in these two worlds. And so often we don't communicate well or at all. The first myth of communication is that it happened.
And it's an interesting parallel because in wealth discussions and dealing with families who are communicating around money and so on, I tell them that problem isn't the money management or the tax advice or the regular old blocking and tackling. It's the communication amongst and between heirs. And then if you get that wrong, that multiplies any sorts of mistakes or missteps along the way. And it sounds like that's a just parallel to what happens in the programming world.
It is. And it's a really huge problem because one of the first places where communication breaks down is the fact that most lay people have no understanding of how software design works. And I use that word carefully because outsiders tend to think of it maybe as coding or programming or software construction, which is completely the wrong words, the wrong metaphor, the wrong connotation. Building software is not building software, it's designing software. It's a design activity. The building parts, when you press the compile button or the deploy button or you run the interpreter, and that's mechanical and straightforward and not really interesting or important unless you're a compiler builder. But for the rest of us, it's just, boom, that's the mechanical part. It's all the rest of it. It's the design. It's the hard part. That's one of the dangers and risks that we run into is because of the time pressures, we rush to solve a problem. Something has come up, bang, quick, here's the first thing off the top of my head, here's a solution. That's the wrong way to go about it. You want to always have at least 3 different solutions in mind before you even open your mouth. We don't do that, of course, but that's what we should do because that means you're spending some time being uncomfortable and actually thinking through and working through the problem space and understanding it. We're in too much of a hurry to get an answer, and we really should spend some time understanding the problem better first.
What is the role of compromise and creativity in that design process and then ultimately the implementation of the solution for it? You mentioned that communication is really one of the most important parts of software design, and it sounds to me like compromise and creativity are natural extensions of good communication. Maybe dive into that a little bit. When you've got talented people who have different ideas, how do you get them going in the same direction on something?
Everything gets more difficult with more people. And this is why a lot of Agile thought says you really want smaller teams, 4, 5, 6 people, maybe 8. Maybe 10 on the outside. You just can't function well with a team of 25 people, 50 people, 500 people, whatever it might be. We don't scale that way. And even with a small bunch of people trying to discuss, debate, compromise, collectively understand problems and be creative, all too often it just devolves into the loudest voice wins. But some of us start off quiet and need time to think. Some of us think out loud and will just say stupid shit for 20 minutes until our thoughts coalesce. I tend to do that. I will just ramble and ramble with whatever ideas are knocking about in my head until something coalesces and makes sense to me. And people who sit there and are quiet until they have something formative to say get very annoyed because here I am spouting these crazy tangents that don't make any sense yet. But they will eventually. I'll get there. So everyone has different cognitive styles. And trying to reconcile that and work in a team is probably the hardest part of the job, I think.
So when you're leading a team, you've identified a problem that needs solving or an opportunity that can be capitalized upon. Talk a little bit about the intersection between the team leader and, say, the management person who is allocating resources to what you're doing. I would think that, and I've seen it in the financial services world somewhat up close, where you have people who are in charge of your destiny who have little understanding of what you're doing. They're relying on the team leader, but at the same time, they have neither sympathy nor empathy to the problem at hand, nor the resources required to fix it. Have you got any experiences on that where that's been solved or worked around? And does that go back to communication as a way to try to fix that and integrate well with the organization as a whole?
It goes back to the flip side of communication, which is trust. And this is what is sorely lacking in most organizations. And one of the key symptoms of that is this idea of assigning work to a team and assigning tasks and pushing all that down onto a team in a sort of thou shalt manner. And what you want to do instead is flip that around. You want to give the team the resources they need, make them understand the pressures of deadlines and times, and maybe there's a trade show coming up, maybe a competitor has a product, whatever the business pressures are. Here's what we're up against. Here's the problem. Now I need this team to go and solve that. And however you organize yourself to do it, whatever you need to do it, it is up to the team to do that. So you see articles in places like HBR and stuff, Forbes all the time. You want to push the decision making down to the people doing the work. That's a pretty basic management tenet of enlightened organizations because, as you say, someone who's a few steps up in the management chain won't understand the issues, is not able to make an informed decision about these things. So you really want to push that down, give the autonomy to the team so that the team understands where everybody's supposed to be headed. You've got to be transparent about that and make that clear to the team, but it's on the team's shoulders to get it done. And the worst way to kill that is to start micromanaging, putting in artificial deadlines, artificial milestones, making them do sprints. I'm not a big fan of Scrum. We can talk about that later if you like.
It's one of those things in upper management levels where, to me, the concept of career risk drives a lot of overly safe thinking, and then B, what you described as artificial speed bumps and milestones in order to support their narrative back up to their bosses. And that's the part that scares me the most. And I can envision as it moves into an area where those management types vaguely understand at best what's being achieved, that trust is difficult to deal with.
That's exactly why you see a movement these days to really emphasize continuous integration, continuous delivery, CI/CD systems. The principle being, I can absolutely understand the risk and fear of throwing money at a development team or development organization and it being a black hole and not seeing any results. And the newspapers and big government contracts are filled with stories of organizations that went off for 6 months, a year, 2 years, 3 years, spent tens of millions of dollars, hundreds of millions of dollars, and ended up with nothing to show for it. The project was a disaster. That happens. That still happens. So there's definite well-founded concern there, I think, on the part of management. The way to get around that is with continuous delivery. If you've got a team that's producing some small increment of value every day, not every 2 weeks, not every month, but literally continuously. Here's another bit of a feature. Here's more of this other feature. You get this continuous pipeline of things coming out. That's much easier to gain trust. It's like, yes, we are producing some things, and it is at this particular rate. Now, if that rate's not fast enough, that's another discussion, and there's really not much you can do about that. The speed of a particular team is a constant, at least in the short term. You can do things to beef that up, but those are longer-term solutions. So you have a team. It is producing work at this particular speed, and as long as it is reliable and continuous, then the act of governance over that team becomes a lot easier. You can do forecasts that are simple linear extrapolation. Team goes this fast, and if you break your features down small enough, you can pretty reasonably say, we will have this many things ready by this particular date. And that gets you away from this going dark for whatever, weeks at a time, 6 weeks, 2 months. And then there's a big milestone and a big demo. The world really needs to move past that because that's not how the world works anymore. The time frames are so much shorter. The competition is so much more intense. Really, the only way to get around that is just to be continuously generating stuff and continuously evaluating and monitoring it, not having big handoffs and milestones. The lean people are all over this. Any gate in your process where there's a handoff, the lean people say that's waste. Straight up. It's a waste. It's a waste of time, energy, money. You want to avoid that sort of thing. And yet I was talking to someone just the other day who had multiple teams in the organization, and their biggest question and their biggest focus was this static arrangement of how they would have all their teams build something and then wait and hand it off to the next, which then had to build it and wait and hand off to the next. And the whole thing sounded like one of those dominoes setups where you tip the one at the end and then it goes for 20 minutes and it rings the bell at the end. It's like, you can't do that in the year 2022. You can try, and the corporate graveyard is littered with folks who have stubbornly stuck to those sorts of ideas, and it just doesn't work anymore.
You've taken a lot of this wisdom and your technical background, and you and Dave Thomas went and wrote Pragmatic Programmer. How did you meet Dave?
Through a mutual friend, basically, a kid I'd gone to college with, who Dave had later worked with over in Europe. And our mutual friend was working at a large company doing banking services, actually. And he had this hardware, software, turnkey solution they'd bought that was putting $1 billion through it every so often, a small system. And it was reaching end of life. And they wanted to replace it entirely with a system that they owned internally, so they wouldn't have to be held captive to whatever vendor it was. So it's one of those nightmare kind of scenarios. There was a hard deadline when the equipment was being pulled out of service. There was not really a lot of documentation. There were some protocols, but the people who worked with it knew that, well, yes, it says in the documentation that it does this, but what really happens is these other things. But that turned out to be what saved us on that project. We had really exclusive ear of the person that knew all the ins and outs of the system. And we could literally sit there co-located and as we're typing, have a question, say, hey, what happens in this scenario? And they would answer and say, oh, you need to do this, that, and the other thing. So we had that very tight feedback loop and were able to pull the project off. So Dave and I realized working together that we had very similar viewpoints as to how software should be written and how a project should be conducted. And as we were consulting and going out and working in the world, we realized that almost every one of the clients we saw was doing it wrong. And by wrong, I mean they were doing stuff that was not generating value, that was hurting the developers, it was hurting the user experience. Leadership and the sponsors weren't happy with it either. So when I say, I don't mean right or wrong from any kind of purist standpoint. I mean it wasn't working for them. They were doing stupid things. So we figured, okay, just to save us time going into a new client, we'll write this little white paper of, hey, maybe you should think about development this way. Maybe you should do these things and don't do these other things and think about it this way. And we had our little sort of favorite pet stories and anecdotes and jokes and things that we used. And we thought we could just write that down, make that part of this white paper. Of course, like most software projects, it grew in scope. So instead of a little white paper, it became the Pragmatic Programmer book.
You talked a little bit about the writing process there. You go from writing the Pragmatic Programmer and being an author to becoming a publisher of other people's work. Talk about that process and how you, A, saw the need, and then B, decided to form a company around it.
People have described that as the leap from programmer to author to publisher. And it wasn't really a leap at any point. It was a slow, gentle slide before you even realize it. So I had gotten good, Dave had gotten good as programmers, and we wanted to share what we had learned. Initially, for very selfish reasons. We wanted to save ourselves time going into a new client and help bring them up to speed with some of the basics so we didn't have to repeat ourselves every time we went in. And that's how we started getting into writing. It wasn't just the book. I mean, we did a lot of blog posts at the time and conference talks and these sorts of things, trying to get our opinions, which were generally fairly contrarian to the mainstream thought at the time. It's like, well, no, everyone's doing that, but that's arguably wrong. Try thinking about it this way. Do this instead. And so we got good at that. And in the publishing part, it was funny. So we're writing the book, and we knew nothing about writing books when we started. We knew nothing. And we figured that the publisher would take care of a lot of things. And they did. But there was an awful lot that the publisher did not take care of. And we had heard from friends nightmare stories that most publishers wanted you to write the manuscript in something like Word, and then they would typeset it, and they would add the code samples. They would retype your code samples into the book and this and that. And people complained that it introduced typos and the code wouldn't run, and then you'd get people unhappy. So we figured we would typeset the book ourselves. And that way we would have control over all the code inclusion. And we set up a simple preprocessor just to include the code live from disk. So we could have it out there running like a real program with tests, and then we just include that into the manuscript. Because, I mean, that's what you do as a programmer. You wouldn't do this manually.
You really particularized your company around the needs of your readership above and beyond just publishing books. It's more than that. It's an education / immersive experience.
We really started off with the premise that we wanted to publish books that would be things that we wanted to read. Even before we got to that point, I mentioned we were doing blog posts and conference talks. We had the same approach setting up conference talks. Everyone has sat through conference talks where the poor speaker is up there mumbling into their notes, reading slide after slide, and you kind of want to gnaw your leg off just to get out of the hall. And both of us determined early on we did not want to be that kind of speaker. So we made a very deliberate attempt in both of our individual and collective presentations to be present and put in some humor and relate the things where we tried this and it totally went wrong. It blew up in our face, and here's why, and here's how you can avoid that. Being honest with folks of our successes and our failures. People don't realize this, but one reason I can say all these things about what works and what doesn't, a lot of the bad habits and mistakes and things that go wrong, I've done them. I've been there. I've done the stupid stuff. I know it blows up. This is not theoretical. I've had things blow up in my face all the time. So we come from that. We know what it's like being in the trenches. I think that has just carried through.
Having that community and the credibility within the community ultimately is how you generate that next generation of authors that are going to help take things forward.
Absolutely. And we've been really fortunate to be in a position where a lot of prospective authors come to us. We do some going out looking for other people, but a lot of folks simply come to us when they have an idea, when they have a burning passion about their topic. So they have an idea, but they're just bursting with excitement over it. And that level of enthusiasm is contagious. And you can really tell when somebody is honestly enthusiastic and appreciative of the tech that they're writing about and really thinks that you should try it because this is going to help you out and this is cool, versus an author who's just phoning it in.
The energy and the excitement that you have, the technical prowess, the business development, the broad lens through which you see a lot of the problems, the product design and the programming, et cetera, that's helped to generate the Agile Manifesto. Can you talk a little bit about what that was, what that is, and what you're trying to achieve in these broader concepts that you're espousing?
The Agile Manifesto is a whole story unto itself, of course. The short version is this was a really remarkable convergence of a bunch of like-minded people that were on the forefront of the prevailing thought at the time. And the 17 of us that got together was a vaguely random assortment. There were other very smart people who were invited who couldn't make it just because of scheduling errors. There were some very bright people who didn't get invited because we didn't know them. Nobody in the circle happened to know them at the time. So it was a little bit random, but everyone who was there was at the top of their game at the time. We were all in this notion, this kind of backlash of the mainstream way of doing things at the time because it wasn't working. It was a very process-heavy, period in time where you had to have all kinds of written documentation outlining what your function would do and how it would do it in pseudocode before you could actually go and write it. And there were milestones and handoffs and signatures and just very, very process-heavy environment. I personally was involved in a couple projects where classic analysis paralysis, they'd fire up rational rows or whatever at the time and do all these diagrams, papering conference rooms, filled the walls with diagrams. 2 years go by, not a line of code gets written. $25 million down the tubes. I had this happen to me personally. Everybody else had this happen to them personally. We all experienced these massive failures from both programmers and management and sponsors not understanding the fundamentals of how software gets created. So what we wanted to do as a group with the manifesto was try to outline the simplest terms we could, what we thought were the most basic principles. If you put your focus on individuals and their interactions rather than processes and tools, if you put your focus on software that actually worked, that ran, rather than anything that you would write about it, if you focused talking to the end user, working alongside the customer, instead of going through a legal team and contract negotiation and whatnot, if you valued responding to a change, adapting in real time, instead of stubbornly sticking to, well, this was the plan, by God, we're executing on it. In hindsight, what's kind of funny is I think we should have harped on the importance of feedback more than we did. Because anything you do, whether it's a meeting, whether it's code, any activity, should all be about designing how do we get the feedback. And with a short feedback gap, minutes, hours, not weeks or months, because that's the world we live in. But it's funny, we talk about the manifesto, and people still get hung up on the very first principle. It's almost not even worth talking about the second through fourth principle or all the stuff on the next couple of pages, which honestly I haven't even read in years. The very first thing, individuals and interactions over processes and tools, we still can't get that right. We are still hung up on that very first principle. There was a thing the other day, one of the large consulting groups, which I won't McKinsey name, they had this diagram. It was all static hierarchies and charts and very hung up on the static relationships that this is where you want to put people and tell them what to do. And it's like, no, that is exactly not what you want to do. Any of these organizations that come out with a process model that looks like a map of the London Underground, no, that is, quote, wrong. That's the wrong way to do it. The very first principle says individuals and their interactions. It's a dynamic system, not static, over processes and tools.
It's amazing, too, because I've talked to a couple of psychologists on my podcast who talk about if you don't understand how human beings not only learn and interact, but how they solve problems, and that's an intrinsic and individual characteristic of everybody, then you're missing the boat. It's difficult to put people in the right boxes anyway. It's very interesting to see from a programmer and someone for whom processes and tools would seem to be the lingua franca of getting things done, that the individuals and interactions are important. It's a breath of fresh air because it's something I think that people have lost their way in terms of thinking about this stuff.
It's ironic because back in 2001, when we came out with the manifesto, naive young me thought, well, okay, we're well on our way to solving this problem. We've identified it. We've said what people should do. Yeah, there'll be some shakeout. It'll take some time, but we're on the right path now. Silly me.
As we move forward here and talk about the future of the industry, the future of programming, software design, architecture, what are the themes that are interesting to you right now that are dealing with the state of the art?
There's some really positive, interesting, neat things happening out there. There's some real disasters. The whole current web programming environment is a nightmare. This is like one of those things in the Industrial Revolution where you've got the giant gears that they're mashing people to death because we haven't figured out how to put safety guards on them yet. It's that level of, okay, we've got to mature a little bit here because things like NPM and its dependencies and the whole mismatch of trying to wedge application development onto what was originally just a simple document presentation format. It's embarrassing. The whole thing is kind of embarrassing, and it'll get better. There's a lot of neat things on the horizon that I think will come to fruition that'll make that better. So we can count it as growing pains at the moment. If you see what people are doing with the Rust compiler and the Elixir systems, much better error messages and handling, much more developer friendly. I think in the old days, there was a sense that compiler writing was so hard, you kind of chewed out whatever error message you could and you just got on with your life because there was so much more to do. So you run to the classic problem again, looking back to C++, you leave off a semicolon, you can get 6 pages of error messages. Instead of bozo, you left off the semicolon. And there's technical reasons why that's harder to report on and this and that. But the newer things are much more built with the idea that you're going to have version control. You're going to have unit testing. These ideas aren't bolted on anymore. They're sort of baked into the fundamental assumptions of the language and the environment. So it's nice to see that level of maturity happening that's making the developer experience more friendly and more usable than the stone knives and bearskins that we dealt with up to this point. We've got a long way to go still, don't get me wrong. There's glimmers of hope.
What would your advice be to younger programmers?
It's a great time in particular because I think some folks have forgotten that when I was young and coming up, you had to make a substantial investment if you wanted to learn programming. I remember there was the popular C compiler at the time was $495. You had to buy the compiler. You had to buy the tools that you wanted. And for the most part today, if a language isn't open source, nobody wants to deal with it. If a framework's not open source, they better have a really good reason for it. Even then, people will shy away because there's just so much risk there in vendor lock-in. So the upside of that is, do you want to learn Elixir? Download it and go. You want to learn Rust? Download it and go. It's all right there. And all the libraries and frameworks and bazillions of tutorials and educational resources, it's all there. All it needs is time. So then it becomes a matter of taste. It's like, okay, what's a good first programming language? I still recommend Ruby. I think that's one of the better first programming languages as opposed to, say, Python. I think Python is better as a general purpose. Let me play with a bunch of libraries and prototype and do a bunch of things. But it's got enough weird corners and irregularities. From an educational standpoint, I think Ruby's a better choice to teach clean design principles and present the least number of surprises and gotchas to the student. Even before you get to that point, if you're talking younger children, middle school and earlier, you probably want a graphical environment, something like Squeak, where you can get a GUI that looks like building blocks. So you can't really make a syntax error because the for loop only glues together this way visually. And something like that to get over the major concepts first, and then move to a more traditional text-based language. I've known some kids that were my kids' age that started off that way, and they're working at SpaceX and Amazon and Google now. So that's a perfectly good way to start.
As we wind down here, you do things more than just programming and publishing and architecture, etc. Real Renaissance man in terms of your music and fiction writing and woodworking. Maybe talk a little bit about that. I think it's always interesting to see what people are interested in doing away from their day jobs. And did you take any lessons from these other pursuits that have applied to the programming world?
I think I get bored really easily with things. So I like to try a lot of different things. But mostly, I like building. I like creating things that weren't there before. Each one of my hobbies addresses that from a different angle. So woodworking, that's an obvious one. That's a very tangible thing, whereas all these bits and bytes are just, and even music, it's all very ephemeral. There's really nothing to get your hand around. But woodworking is very tangible, very solid, and I find it interesting in the sorts of problems that come up and the way that you have to solve them uses a different area of the brain, because the problems are very physical. How do you keep this piece of wood from moving? How can I orchestrate this cut so that the wood's not going to fly off and shear my kidney with it as it goes? It's a very different mindset. It's a nice change of pace because woodworking, especially hand woodworking, is a much more calmer, reflective activity. you sort of have time to think about your next move. You don't have that kind of panicky rush like you do with the commercial pressures of programming. Music production, I love playing and producing music. Again, you look at the march of technology, I've got some incredible toys that would have cost millions of dollars back in the heyday of the recording studios. It's just amazing being able to do things that were so hard 10, 20, 30 years ago, and now there's a plugin for it. I can get that sound. You want to do something that sounds like the Beatles recorded it, you can get a plugin using the actual equipment from Abbey Road to get that sound, whatever it might be. So that's fun in its own different way. Fiction writing, which I started a couple years back, to me is more similar to coding than the other activities because you're world building. One of the things that attracted me, I think, to programming in the first place was this idea that you're building your own little world. Even if it's a payroll program or inventory or whatnot, all the abstractions and how the stuff relates to each other and how you build up your understanding of it, you're building a world that you control and that you're designing as it goes along. And that's a lot of fun. So writing a novel, you're building a whole world just the way you want it. And you can get the characters to do just what you want and interact and thread a plot through the whole thing. So it's kind of like programming, but there's no compiler.
What a fertile mind. What a thrill to speak with you, Andy. How do we stay in touch with you and your various pursuits?
Simplest thing, Twitter is where I'm hanging out these days. I am Pragmatic Andy on Twitter. Feel free to follow me there. I tend to post all of my various endeavors there. On the web, toolshed.com is my homepage, and I post articles there and occasionally on my ramblings on software and other matters. My musical pursuits are at strangespecial.com. My latest novel, Weatherly Hall, is about a haunted house set in the future after the Second Civil War in the U.S. So you've got a haunted house, and then you've got drones, too. It's a fun psychological thriller, and that's at weatherlyhall.com. My sci-fi books are at conglamora.com. And then, of course, the books are at pragprog.com for the tech books. And then I've been playing around with this idea of methodology and making kind of an anti-method called the Grows method. And if you go to growsmethod.com, we're big on the idea that you can't have a process. Process is not going to save you. In fact, when you try to stick to a process, you're cutting your legs off. What you need are these particular skills and understanding how people learn, how we learn in groups, how to communicate, how to do all this effectively as a team, these sorts of issues.
Really cool. And on the Grows method, we may have to have you back on to talk even more about that. The rest of the contact information will be in the show notes. Andy, thank you very much for being on.
Thanks again for having me. Really enjoyed it.
Thank you for listening to this episode of Wealth Actually, hosted by Fraser Rice, author of the book Wealth Actually and a leading private wealth manager. Head on over to wealthactually.com where you can subscribe to this podcast, get your own copy of the Wealth Actually book, and connect with Fraser directly. We'll see you next time on Wealth Actually.